Hello, good morning everyone, and welcome to this webinar. I will be your presenter today, but together with me, I have my colleague Elias Yusfi, and he will be conducting the main part of the WebEx today. The content of today's WebEx, it will be around 1 hour, where we will be very shortly describing the reuse company, and I will be also introducing my colleague, Elias. Then he will be explaining us why using patterns to increase the quality of your requirements, and to be more specific, we will be showing today the master patterns by Sophist. And also, Elias will be showing you our RAT rich authoring tool to write requirements using these master patterns, and also having real-time quality assessment of the quality rules provided by the Sophist set of rules defined in some of the Sophist books. Then we will follow with a live demo, and finally, it will be your turn to ask your own questions, and we will be glad to answer your questions. About the reuse company, the company was created in 1999 as a spin-off of university in Madrid. Today, the company includes people from different disciplines, software engineers, systems engineers, also artificial intelligence people, linguistic people. So this is blending a wonderful set of skills in the company. The company is headquartered in Madrid with local offices in Stockholm and London. And our aim is always to offer knowledge-centric approach to leverage systems engineering activities in our customers today, focusing on improving the quality of your requirements. Regarding research and development, for us, this is still a very important part, because it allows a company which is still a small company like ours to keep the pace of our very large customers, because in most of these European research projects, we are partners of what eventually could end up being our customers. So in the past, we have been having very important projects like Crystal for the quality of requirements and the definition of patterns. So I can tell that most of what you're going to see today about patterns and requirements, quality rules, and correctness, consistency, completeness was initially for us defined in this Crystal project that was a large Artemis project. But today we are also facing new challenges in terms of new projects like Arrowhead, or by the way, some of the projects that are in the future part are already present, like New Control or Embrace. So what are the three main disciplines of the reuse company? We like to use the acronym TRC for the reuse company. But if you allow me a little change, this acronym TRC can also be mentioning what are the three main disciplines that we cover with our technology. This change is just due to the fact that in Spanish, quality is spelled with C, while I guess that in most of the rest of the languages in the world, quality is spelled with a Q. So if you allow me this change, then we can also say that TRC becomes TRQ, just for T for traceability, R for reusability, product lines, and fine-grained reuse, and Q or C in Spanish, Q for quality. So these are our three main disciplines. Of course, today's webinar will be more focused on quality, of course. With regards to customers, still today our main focus is in aerospace and defense, including companies like Airbus or Safran Group or Thales Group, IES, a German company, Ariane Group, and other companies whose logos I cannot include here, but it is including, for instance, the French Ministry of Defense or the Norwegian Ministry of Defense, MBDA. Then if I go to the second line, energy, we are having very interesting projects with some of these customers like Fusion for Energy or ITER. These both are fusion projects and fusion energy projects. then EDF, Electricité de France, or Repsol, the oil, Spanish oil company. Regarding automotive, I can also only include this logo of Renault. However, we are also having now customers in the automotive industry in Japan, like Honda or Toyota, and also here in Europe, like Volkswagen or even Toyota Motor in Brussels. And we have started last year with large automotive American companies like Ford and Chrysler. And then the more you go down, the less the less systems engineering and the less requirements we are dealing with in healthcare and other industries. So before I hand over to Ilias, just a brief a brief presentation of him. He's a sales and consulting engineer at various company. He joined the company a couple of months ago, but now I'm very happy to have Ilias presenting you this webinar. He has experience in energy engineering and life cycle assessment methods in different industrial sectors such as energy and aeronautics. Ilias' main missions are international sales of our systems engineering suite and systems engineering solutions, consulting of our customers, and account manager. And his main interests include knowledge management, industrial engineering, requirements engineering, and sustainable engineering process. So I hand over to him, and he will be presenting you this webinar on ensuring completeness, consistency, and correctness with the master patterns by Sophists and the requirements of the rich offering tool. So Ilias, I hand over to you.
So thank you, Jose. Hello, everyone. So this webinar will be focused on the Sophist patterns, and before going into the subject of Sophist pattern, let's see some of the reasons why it's important using patterns and how they can help improve the quality of requirements. And let's start with historical facts. The first introduction of requirements happened in 1998, and things in the requirement sector. You have it started with the military, so the project in the UK in this case. Then it was used in the development of natural language processing, and patterns are also known as boilerplates or templates, and first used in the software engineering and then extended to systems engineering, and of course now inside the INCOSI there's a working group on patterns. So let's see some of the benefits of patterns. The patterns represent the structure that every correct requirement should meet. So it's a sentence structure that has to be followed, and we'll see some examples with the Sophist patterns. There are different types of requirements, and therefore the patterns can help distinguish the types of requirements in the document. You can customize for every domain, customer, and content the patterns by introducing some domain-related information. We also create libraries with sets of patterns so that they can help improve the quality of requirements, and we see some examples. And they represent a sequential set of restrictions, so it's linked with the structure, and the idea is to give a mandatory position of every word to construct the structure. So for example here, when it is detected, the car should show a nice icon in less than 0.5 seconds from its detection. So in this case, following a pattern, you can identify where the idea is, where the information is, and in this way you can retrieve information from a document. Patterns are one of the layers of what we call the ontology. So the concept of ontology is based on 5 layers, and the more you go up in the layers, the more information and the more completion you have in your ontology. So first layer is vocabulary. So you need a dictionary related to a domain or a general dictionary to start having a database that can be used to write requirements. You have then the system conceptual models and architectures that define the relationships between elements in the system and relationships between different environment systems. And then you have patterns. So the patterns are the authoring structure that you have to give to the requirements so that you can have well-structured writing requirements. And then you have formalization and reasoning, which enhance the quality of your ontology. So let's see some examples of what we call quality metrics. So following patterns, you obviously follow and some rules, some ground rules regarding the writing of requirements. And with the same idea of the ontology content, the more you go up in the construction of the ontology, of the system knowledge base, the more you have in regards of quality metrics, quality rules, and the more quality you have at the end of the analysis. So let's take an example here with our RAT window that we will see a bit later. In this example, the ECU is not known as an acronym, so it demands definition of this acronym before in the ontology before using this as an acronym for the requirement. There can be also measuring of the completion of some information. For example, the measurement. If you put an exact measurement, maybe it would need tolerance. This is some rules that we can add to the ontology. Then let's have an example of the passive voice, which is also one of the rules that we will see in the Sophist set of rules. So, for example, the metric can be defined to be applied only to one part of the sentence. So, in this case, in the condition, when the ABS is activated, you have a passive voice, but it doesn't come out as an error for the metric because it was purposely mentioned when creating the metric that the passive voice is allowed in conditions, which is often the case, and we see in the Sophist patterns that with some of them we have passive voice. Then we have also completeness metrics. For example, the property definition of different elements of a system, and if you have 20 elements and only 15 of them have their property defined, obviously the metric will tell you you have 5 requirements missing to define completely the property. For example, here the power consumption. Patterns can also help you retrieve information, as said earlier, and this relies on this pentagon-shaped layers that we call the ontology. So if you define the ideas, the verbs, the system elements, and the equivalence that can exist between different verbs, regardless of the order of the ideas inside the requirement, the tool will be able to identify these 2 requirements as equal in terms of meaning, because you have the same information and the same purpose. Patterns can also help retrieving information, as said earlier. So introducing a pattern and processing it into an unstructured document, and then use this information to integrate it into requirements management tools like DOORS or PTC Integrity, and also can be used in Excel. And this is another example of the notion of placeholders. So in order to retrieve additional information, so if you know where the system is, you can retrieve the word that is just before, for example, a communication system or a braking system. And last notion that is very important here is the knowledge transformation. So when writing a set of requirements, here there's an example of composition of a system. We have a system representation language that takes the information of the requirements and builds up the relationship between the subsystem and the system itself. And then the tool is able to convert this language into system modeling language, like for example SysML or OOL or Ontology Web Language, or the object the ORM language. So this way you see that the requirements written can be converted into a chart with the composition of each element in the system. The patterns inside our systems engineering suite are, some of them are included in the out-of-the-box database that come with the installation of the tools. We have also some specific libraries, for example, the library of the Sophist patterns. Patterns are managed in KM, as we will show you in the live demo. They are managed by the knowledge architect, which is the main user of the KM, but are also requested by the requirement authors when using the RAT rich authoring tool that we will also see during the demo. So I know this is a very overall general presentation. You know that we have a webinar section into our website. So here are some links that you have the opportunity to visit if you want some more information about writing with patterns to enhance quality and how to build up the quality metrics inside our tools. So let's talk about the Sophist patterns. So let's present the Sophists and their work in order to help in the requirements engineering phase. So Sophist is a German training and consulting firm created in 1996. There were 3 at the beginning. Now there are around 60 members. Their specialization is in requirements and systems engineering. Also, a fact is that they are co-creator of the IRAD standard, so the International Requirements Engineering Board, and they provide documentation with 100% tool-neutral methods and knowledge. In the website, you can see a section which is called the Vision for Free section, which are free publications and brochures regarding requirements engineering practices. And in this case, we based our implementation in 2 of these brochures, the master patterns, which is in German and describes the requirement patterns to enhance the structuration of the phase of requirements documentation, and the RE primer, which is an overall description of all the phases of requirements engineering. And this is where the set of rules that has to be respected when writing the Sophist patterns. And then you have the first brochure with the overall description, and the Sophist master patterns, where all the different patterns are described. So let's begin with the description of the patterns and the nature they have to help writing requirements. So Sophist patterns are cross-domain patterns to express system requirements. There are 2 types of requirements in regards to this brochure: the functional requirements and the non-functional requirements. And for each of them, you can introduce a condition or decide to write without condition the requirements. So the master patterns are used for the structuration of the syntax of requirements. They help having uniformity of sentence structure. So, for example, uniformity of linking words in conditions, or the uniformity of modal verbs. They help building the scope of each set of patterns, so in order to identify functional and non-functional patterns. And they help also in the scope of conditions, and there are 3 different condition master, the name of the pattern, that we will see a bit later. So let's start with the functional requirements. So the functional requirements are the requirements, the patterns that help writing that help describing the functionality of a system. So yeah, there are 3 different cases to express the function master: the independent system activity, the user interaction, and the interface requirement. And this is the scope, the general scope. Have also have to know that the function master can have a detailed version which enables to give more context and, for example, describe the verb or the object. So let's present each of these different solutions for the functional requirements. You have 3 different paths. then the dependent system activity. In this case, the system starts and performs automatically a function. So this is the path that doesn't have any block or a void block after the modal verb. You have the user interaction. In this case, the system enables the user to perform a function in order to achieve the goal that the user is aiming. And in this case, the system relies on the user to perform the function. So the system provides the user, or in this case, it's called the actor, with the ability to perform the function. And the last type is the interface requirement. And in this case, the system relies on another third party, which is not a user. In this case, the system shall, should, or will be able to perform a function. Here you have an example for each of these patterns when implementing them into the knowledge manager, our tool. So the view enables you to see the description of the patterns. You have an example, and you can see the syntax. And a bit later, when explaining different sets of levels of requirements that you can build inside the tool, I will present you the meaning of the colors, because there are different colors, as you can see. Then let's take another example. You have the user interaction pattern, which features the provide actor with the ability to, and the last one, which features the be able to, which is typical of the interface requirement. So then, the second type of requirements that you have, second nature, is the non-functional requirements. And these requirements are used when you want to address other characteristics that the system functionality, but these elements will have an impact on the addressed functions. For example, the temperatures, the range of temperatures of the system functionality is not the functionality itself, but it will have an impact, of course. So in this case, we have 6 different subcategories as described in the master patterns brochure by Sophist. Have the quality requirements, the technological requirements, user interface, requirements for other delivery components, requirements for activities to be carried out, and the legal contractual requirements. And as you can see, one of the patterns that can be used for all these categories is the property master. And then the environment master and process master apply to very specific cases. And let's see how are these different patterns. So let's start with the property master. So as you can see, the property master relies on the characteristic of the system. Let's take, for example, this capture of the knowledge manager. So this is how the structure is built up in KM. The environment master, in this case, we describe how the system shall be designed to operate in certain conditions. So in this case, the subject is the component of the subject matter. So you can see an example here of how it is constructed inside the KM. And last type is the process master. In this case, it relies on the actor as the trigger of this pattern in order to describe the operational scope of the function. So then, for either the functional or the non-functional patterns, it's possible to use these optional conditional master patterns. So you have 3 types, as said when presenting them. The logic master, which is introduced by the conjunction if, the event master introduced by the conjunction as soon as, and the time master introduced with the as long as conjunction. So again, let's have an example with the construction. And in this case, we'll see a bit more in detail how the colors are, what the colors mean. So the red color is a sub pattern. It means that there is a pattern inside. So in this case, the condition master is 3 different patterns that are called depending on the condition. If you take an example, the pattern with if, the logic master, then you have a logic master block, which can be, as you see, we have 2 main paths, one beginning with a compared object and the other with system or actor. So these are the 2 paths, and inside these 2 blocks, we see that the color is still in red. You have the logic master 1, which is a compared object auxiliary verb not value, and here are some optional terms. For example, the not can be or cannot be used, and the logic master 2 introduced and beginning with the actor of the system. And you see there are still red blocks, meaning that the actor is defined also as a pattern. So let's see a little the concept of the knowledge library. So the knowledge library is the combination of knowledge items in order to be used for the definition of requirements and the measurement of the quality. So these can be specific to a domain, for example, the ECSS library, or cross-domain like the INCOSI rules. And these can help in many areas of the definition of requirements, reducing time, enabling interoperability, and enabling an easier verification of the requirements. So some of the knowledge libraries we have are displayed here. So the INCOSI, EARS, NISA, ISO 26262, and the master patterns, which is the one we are currently describing. So the KM is the tool to manage the creation of the patterns. So our library is available in English and German, which are the 2 languages of description inside the master patterns brochure by Sophist. So for example, in the German version, you have 65 patterns and sub-patterns, of course. And let's take this example of the way it is constructed. So as said before, the red blocks are sub-patterns. For example, an actor is defined as an article with an adjective, which is obviously optional, a number, optional as well, and the cluster actor. The cluster is the description, the conceptual structuration of the concepts. So, for example, what are an actor, and we have the hierarchy that is defined in order to sort the ideas. Another example, block, and then you have the example of the number and unit, and the details of the process verb. So, and this is a view when modifying a pattern. So now, after creating the patterns, they can be used for the creation of rules, and in this case, we'll talk about the rules defined in the RE primer, which is the other brochure we presented. So these rules are implemented inside RQA, Requirements Quality Analyzer. So we have 18 rules inside this set of rules described by Sophist, and 3 levels of priority. And the aim of the RQA is to convert these rules in what we call, and I presented it a little earlier, the quality metrics. So one rule can be converted into one or several metrics in order to describe and measure the quality. So the metrics rely on this 3-dimensional approach, which is a CCC for correctness, consistency, and completeness. And this is described in other webinars with more details and how to create metrics with this approach. Let's see an example here for the rule number 8, which is to formulate adjectives in a way that can be measured or tested. It's easily covered by creating a metric that detects the list we can see here of words that are not measurable, like, for example, flexible or generic. This is a mapping that we will also present when presenting the library. For example, here you have, for one rule, you can have several metrics in order to cover the whole scope defined by the rule. So now let's present you the tools. So first, let's go into the knowledge manager. You see that you have also the RQA that we will present you later, and then we'll finish with the doors utilization. So let's start with knowledge manager. You see that we have the knowledge bases in English, and let's see here, when you open the knowledge manager, you have the first view is the vocabulary and the terminology, which is, as I showed you, the first layer of the ontology. So you have here the dictionary of all the terms. So in the English database, we have around 6,000 terms, and this can be easily built up by importing terms. So we will see an example right after. You have the notion of term tags, which is a classification, a semantic classification of terms. You can modify here term tags, add new term tags in order to enhance the comprehension of the language. Here, let's see an example of importation of terms. So, for example, let's take an Excel sheet with a list of new terms. So this is basically all the vocabulary that is inside the brochure of the master patterns. So in order to import, you select the term, and you can import the terms and sort them into the term tags and clusters. So for example, let's take these two columns. You can also import all terms into the same cluster, selecting the fixed option. But in this case, we'll and integrate these terms into the cluster that we wrote inside the Excel sheet. You see that there is 0 selected terms because they were already inside the library. It's just to see how you can import other words. So for example, if we select the cluster of process verb, you see that in yellow, these are the terms that were in the importation process. So the yellow means that it's modified, and now you have the patterns window, and in the patterns you see that we have the main patterns which are easily recognizable with the Sophist at the beginning of the name. So you can see, moving the pointer on each pattern, the structure. Let's take an example of another sub pattern or auxiliary pattern. For example, the signal. You see that there are 2 times signal because there are some optional terms, as you can write the word signal or not write it, and you can write it before or after the signal. Then we can close the knowledge manager and now go inside the RQA, which is the tool that enables us to create the quality metrics. So here again, the 2 Sophist databases in English and German. And this, as you see, this is connected to doors, and you can select the modules of doors you want to open inside RQA, and you can open several. So in this case, we have 2 modules. And if you open RQA, the first window you can see is the quality control window with the quality view of the different requirements. You can, of course, modify the view in order to better see the quality and export data after analyzing. But this is not the main topic here. Let's go straight to the quality assurance, and let's see. Here you have our approach of progressive creation of quality metrics, known as the belt approach, and like in karate, for example. So we created a sample of rules with the Sophist rules, and as you see, some names are some rules are need 2 metrics to be covered, or can need more if you go up in the belt approach. So for example, when you create a rule, you can define the scope, you can enable or disable rules. And the idea is to first begin with the most basic rules. So here you see the CCC approach to correctness, consistency, and completeness. So you see that, for example, to create a completeness metric, you can select one of these options here. But let's come back to the correctness, which is the set of rules that we have. Important feature here is the authoring pattern groups. These are the pattern groups that will be used when using the rich authoring tool that we will see just after. Let's take an example of a metric, for example, the use of the active voice. So we, in order to set this rule, we created a group of patterns that is called passive voice exception for all the patterns that have a passive voice, and for them we don't want to detect the passive voice. So you can what we call an intelligent metric that tells you you want or don't want to detect. Then before going into doors, it's important to see this property, because RQA and doors are connected, and in this way you can save the quality of your requirements inside doors. And there's this other very interesting feature of assessing quality inline, and this is let's say the reverse process, which is creating a requirement inside doors and having the quality instantly calculated inside of doors without having to come back to RQA to calculate it. So obviously, if you select the assess quality inline, you automatically turn on the save quality assessment indoors, because you have to have the quality view created so that you can then connect to RQA to do the job to calculate again the quality. So you see that the quality inline is activated. So now we can skip the RQA and go into the IBM rational doors. So let's open this set of requirements that we opened inside RQA. So you have two modules, the same we've seen when opening RQA. And let's take this empty module. And in this module, we will see how to create new requirements. The window is looks familiar, but you have this other tab, which is the add-on of the rich authoring tool inside doors. You can insert objects, edit existing objects, and you have this interesting notion of ontology that comes again. And it's very important that every time you modify in the KM or in the RQA either the patterns or the quality, you have to reload. You can quality view so that we'll create it after. So let's start with an example of object. So you see that the RAT plugin is opening. So the first opening is a little longer than the other because it connects to the RQA and KM and retrieves the ontology with the existing data. So let's take an example. Here you see this window, the main window here with the writing pane. You have the correctness metrics summary on the right with the metrics that we enabled, and below the correctness, consistency, completeness summary, and some other features. Then you can activate or deactivate the writing assistance. Let's take an example without the assistance. Here you can see the pattern used for the authoring. You can disable the authoring with pattern. Now let's take an example of independent system activity. Let's write if the system saves customer data, the library shall activate the function connect to the server. So in this case, you see that when writing the requirement, the green frame is appearing, meaning that the pattern is well written, is well respected, and that the quality is high. So now that we saved, you have this first requirement written, you can save. And now that we've created a requirement without using the assistance, we will take an example using the assistance enabled by the rich authoring tool. So this writing assistant is a feature that helps in the writing by suggesting terms relying on the ontology and the construction of the pattern. So here, as soon as you activate the assistance, you see that suggesting terms are appearing. So for example, we took the example of requirements for activities to be carried out. You see the yellow frame, meaning that we are following the pattern, but it's still not completed. And you see the on-the-fly calculation of the metrics. So here, let's write the administrator shall inform the users about the new database. And each word is then processing the metrics. And at the end, you can also press tab in order to easily write the rest of the word. So you see the green frame again, and the quality metrics are all well calculated. So now, if you change here the view and you go to the quality view, before we have to create it. So there is this generate quality view function, and as we activated this property, it saves the quality inside doors. Now let's try to modify the quality. Let's try to modify the quality here by changing a word. For example, shall send the users the new database. It's still high because we don't have any trouble, because send is inside the ontology. Transfer is also inside the ontology as a process verb. But if you change the modal verb and put must, then you see that the quality is moving too low because the pattern group is not found. Because in the Sophist patterns, only 3 possibilities of modal verbs are allowed, as you've seen: shall, should, and will. So now let's try to create another pattern. So let's see that you can use the edit function as well to open the rich authoring tool. And now let's move back to, let's have an example of a technological requirement, as we've seen, which will also feature this interesting set of the passive voice metric. So you see, it follows the pattern, the environment master that we presented earlier. You see that pressing tab, you can easily write the rest of the words. And now we see that by configuring the values, you can write ranges of temperatures. And in this way, when finished writing, you have this green frame, meaning that the pattern is matching and the metrics are all respected. So you see, while saving, the quality is saved also in the quality view. Now, if we misspell a word, you see that it changes instantly, and we would like to design. So this is some of the features that are allowed by the rich authoring tool.
So thank you very much, Elias, for this wonderful presentation. Now it is the turn for the questions. So I'll give you 1 minute to write down your questions. Remember to use the chatting box. You are mute, so you have to provide us with your questions by using the chatting box. Please address these questions to the user, their use company, and not directly to Elias. I will read aloud your questions. So I give you 1 minute for writing your questions. And while you write your questions, I would like to invite you to our next webinar to be hosted next month in March 24th and 26th. The aim of this webinar will be to introduce our library mapping the INCOSE guide for RAT requirements. As some of you already know, we already have a library mapping this INCOSE guide. However, there is a new version of this guide that was released during the past INCOSE symposium in July, and now we are offering this new version of our library as well. So during this webinar, we will show you how we have implemented making advantage of some of the new capabilities, by the way, of our tools in the current version 18.3. We have now a set of more accurate rules that can be either implemented in RQA, Requirements Quality Analyzer, to have offline quality checking, but also, as Elias was showing you today, the same set of rules can be implemented in the requirements offering tool to have real-time assessment of almost all the rules implemented or described in the INCOSE guide. So please provide us with your questions. I give you 1 more minute. Well, we have a couple of questions. First one is it possible to have high quality without following the pattern? Elias?
Yes. So to answer this question, let's explain, quickly again the concept of the RAT. It's helping following the pattern and also checking the quality. So in the example I've been showing you, we had a rule that say you're following the pattern and you're not following the pattern. Of course, if we disable this rule, then you can have the rules respected without the rule of the pattern being checked, and in this case we'll have a high quality. So this, for example, if you don't use the assistant when writing a pattern, this can be a little problem if you want the pattern to be followed. So it depends on the application you want, but of course it is possible. It depends on the quality rules that you set in RQA.
Well, thank you. We have a second question, interesting question to my understanding is, does the library include all the concepts shown during the demo? Or is there a means to automatically find the concepts specific for a given project or industry or discipline?
Okay, so when I was presenting the different libraries, of course, the library that you download when installing the software is called the out-of-the-box library. This library doesn't contain any specific domain-specific information. The idea of the KM is to import the data from different sources, possible sources. If you talk about a dictionary, you can import, as shown, terms from Excel, but you can also connect to modeling systems, for example, Rhapsody or Protégé or other modeling tools we connect with. And the idea is that you can use several sources in order to build up your ontology and have specific domain-specific knowledge. For example, the NASA library will obviously contain these data, and you can load the library easily after having downloaded it, and the library are available on the RIS company website. So it's possible to have more specific data. It just needs the knowledge manager to be fed with this information.
Thank you, Elias. We have one more. Can you deal with misuse of the pattern? For example, an user interaction is described with the third path of the functional master.
Yes. In this case, you can deal with the misuse of the pattern. Again, it's important to make the difference between the pattern matching the frame that is green when you match the pattern and the rule. So of course you have to set the rule to be as specific as the matching that you want. So if you select the pattern of user interaction, but you write the independent system activity pattern, of course there will be a mistake. What could lead to misuse is if you only select the pattern group. So, for example, if you select the pattern group non-functional or functional, in this case, requirement, and you don't select the one of the three paths, of course, you can write in each of the three paths. So it's important to know exactly the pattern you want to follow, and of course, if you select the pattern you want to follow, it would strictly check the following of this particular pattern. So it's very important to use the authoring help with the right level of detail, depending of if you want to use the pattern group functional requirement without knowing the pattern you want to use, or if you want to be more specific in the writing.
Yeah, one more. Have you already integrated some dictionaries such as Oxford Dictionary of English? I will try to take this question from me. Yes, we have implemented some dictionaries. For the time being, not the Oxford Dictionary. However, as Elias was presenting during the day today, we already have different types of libraries. Some are more focused on quality rules or even patents, but some others are also including dictionaries. So, for instance, the glossary described in the ECSS standards, all this glossary has been already implemented in another library. I personally presented this webinar a year ago or so. So all these, whenever you import a library that contains some dictionaries, all these dictionary entries are available for you, merged together with the patterns that are shown. So, for instance, Elias was presenting some particular patterns with clusters like actor or clusters like system, provided that the other libraries already include some items in the cluster of actor or systems. All these names will appear in front of you when you are writing your requirements, so that you will be not only consistent in terms of the structure of the pattern, but also consistent in terms of the dictionaries that you are using. And also, as following one of the previous questions, we can even implement our patterns in a kind of a different way, but similar to how it was described during the webinar today. We can modify a little bit our patterns to be a little bit more open, let's say, so that we can automatically catch new concepts coming from, let's say, legacy documents. We can analyze one of your documents and ask the tool to automatically elicitate the content of the dictionary. We have run out of time. We cannot answer any more questions. Of course, you can address your remaining questions to us by email if you wish, and we will send you a copy of the recording of this session within some few days. So please stay tuned for this recording, and also I would like to join you for our next webinar in 1 month. So thank you very much. Have a good day. Goodbye.